Good morning, students of class 11B. Yeah, now we are coming with a new topic, addition of vectors continued. Addition of vectors we have already seen, parallel of addition of vectors, right? Today we are going to discuss another method, how we can add vectors. When so many vectors are acting on a body in different directions and different magnitudes, then all these vectors can be adjusted by the sides of a convex polygon. Convex polygon. That means you have to see that according as the direction only you have to set the sides of the polygon, right? That means this vector is along this direction. So in the polygon also this vector will be adjusted. Having this length is exactly equal to the magnitude of the given vector, right? All these vectors are set as the different sides of this convex polygon, right? This is vector A, this is vector B, this is vector C, and this is vector D. Then the closing side, all these vectors are taken in order. Taken in order means what? When one vector finish and the other vector starts. That is what is called taken in order. So A, B, C, and D are taken in order. Then the closing side taken in the reversed order will be the resultant of all these vectors. This is another rule using which also we can add so many vectors acting on a body, right? Okay. Now you see this is proved using triangle of addition only. Notes also will be given to you, don't worry, or time to time. When I remember, right? When that comes in my mind, I will, in a regular basis, I will send notes also, don't worry that, right? Suppose this vector is vector A and this is vector B. These two sides are taken in order. Then this side taken in the reversed order will be the resultant of these two vectors. These two are in order and this is the reversed order. So this vector is vector A plus vector B. Triangle of addition of vectors 2 days ago you have seen, right? Now this, suppose this is O, this is A, this is B, this is C, this is D, etc. Okay. So vector A plus vector AB is equal to vector OB. Or vector OB is equal to vector OA plus vector AB we can write. Using which? Using triangle of addition of vectors, right? Now we see another triangle. This is OBC. In triangle OBC also, this vector OB and vector BC are two vectors are adjusted at the sides of a triangle taken in order. So this side and this side are two vectors. This vector is equal to vector A plus vector B. And this vector is equal to vector C. They are taken in order and are the two sides of a triangle. And the third side taken the reversed order, which is that is equal to OC. OC will be the resultant of these two vectors. So by triangle of addition of vectors, vector OB plus vector BC is equal to vector OC. What is vector OB? That is equal to A plus B. What is vector BC? That is equal to C. Therefore, this vector will be equal to what? Vector A plus vector B plus C. Also we can write. Nice. Now another triangle coming here, you see OCD. OCD is another triangle. In this triangle OCD, vector OC plus vector OD are in order. They are the two sides of a triangle taken in order. Then the last side taken in the reversed order will be the resultant of these two vectors. Therefore, vector R is equal to vector OC plus vector CD. What is vector OC? Vector OC is equal to vector A plus vector B plus vector C. So all these three are, right? Yes, plus. So all this vector A plus vector B plus vector C plus D, you will get the resultant of all these vectors acting on the body. And these vectors are having different magnitudes and direction. And these vectors can be adjusted by the different sides of a polygon in magnitude and direction. Accordingly, as the magnitude of this only, you have to adjust the side also. Then the last closing side taken the reversed order will be the resultant of the two vectors. This is polygon law of addition of vectors. And the next is subtraction of vectors. How can we subtract? Up to now, we were discussing about addition. Now, I am going to tell you how we can subtract one vector from the other vector. Right? Subtraction of two vectors I am going to discuss. Right. So we have to subtract a vector B from vector A. How we can do it? Subtraction. Subtraction of vectors. Right. There are two vectors, vector A and vector B. So this is vector A. And this is vector B. Vector B. We want vector A minus vector B. So subtraction of one vector from the other vector is same as adding negative vector of the other with the first one. Okay. That means A minus B can be written as equal to vector A plus minus B. Vector A plus minus B. In this case also, students, we will use triangle law of addition of vectors. How I am using triangle of addition of vectors, you will see very carefully, right? First, this vector is adjusted as the side of a triangle. Okay, this is the side of a triangle. It is subtracted with the same magnitude and the same direction. You will write vector A. Very nice. Okay. Next, this vector B is also adjusted with the same direction and also with the same magnitude. Okay, but we want A minus B. This is vector A. This is plus vector B. In this case, we will not get A minus B, right? Okay. Suppose if a third side is drawn here, that will be A plus. In that case, what will you do? We have to make negative vector B. Negative vector B is a vector which is acting in the same line, but in a direction opposite to that, with the same magnitude. So, with the same magnitude, you will make another vector having the same magnitude of B, but in the opposite direction of that. Then you will write minus B, you will write. Now, these two vectors are two sides of a triangle taken in order. Then the third side taken the reversed order will be what? Vector A plus minus vector B. Am I correct? So, this vector, that means this vector B is subtracted from this vector A minus B. So, first of all, we will take the positive vectors, vector A and vector B. We wish to calculate A minus B. A minus B means A plus minus B. So, we have to create a vector minus B against this vector B. If B is along this direction, minus B will be at an angle 180 in the same straight line, having the same magnitude. My magnitude, because with the freehand writing, some difference will be there. You don't mind that. It will be in the same straight line with the same length, but in the opposite direction. So this vector is vector A, and now this vector is minus vector B. They are adjusted by the two sides of a triangle taken in order, because this ends, the other one starts. Then the third side taken the reversed order will be the resultant of these two vectors. What are the resultant of these vectors? A vector A plus vector minus B. A plus vector minus B. This is equal to A minus B. Vector A minus vector B you got. So for subtracting, what do you do? We have to use triangle law of addition of vectors. The positive vector, first of all, we have to create a negative vector. How can we create a negative vector? It's very, very simple. What is that? We have to draw a straight line just opposite to the given positive vector B, and we'll mark it as equal to minus B. Now the two sides of triangle, one is adjusting vector A, that is positive, and the other is adjusting negative vector B. These two are the two sides of a triangle taken in order. Then the third side taken the reversed order will be the resultant of these two vectors. That is vector A minus vector B. That's also done. Next thing we have to discuss is null vector. What's a null vector? That's the question. I'm writing null vector. Null vector means a vector having its magnitude 0, but having an arbitrary direction. Arbitrary means imaginary. Right? Any vector must have a direction. When we call that a 0, a vector having magnitude 0, but it is a vector must have a direction. Right? This vector has a direction, we call it as arbitrary direction. Arbitrary means imaginary. So what is a null vector? Null vector is the one which is having its magnitude 0 but has an arbitrary direction is called a null vector. So we have seen that when a vector is multiplied by a real number, its magnitude increases by lambda times. We have seen that. Right? If it is multiplied with minus lambda, then it's again its magnitude increases, but in the opposite direction. All these things we have seen, right? In the case, if lambda is equal to 0, if lambda is equal to 0, the real number that we are going to multiply with a vector is equal to 0, then vector lambda a. Then vector lambda a is equal to vector 0. Vector 0 means null vector. So null vector is denoted by a 0 with an arrowhead on top. Right? Am I correct? So this is what is called this, right? Okay. Then if vector b is equal to minus vector a, if vector b is equal to minus vector a, then vector a plus b is equal to, then vector a plus vector b is equal to vector a minus vector a is equal to a null vector. There are so many examples of null vectors we can place here before you. For example, acceleration of a body which is moving with uniform velocity. A body which is moving with uniform velocity means what? In every unit interval of time, the displacement of the body is same. That means the change in displacement is equal in equal intervals of time, right? Then the velocity of the body is a constant value. Velocity, when there is constant value, the acceleration is equal to 0 because change in velocity is equal to 0. When a body is moving with uniform velocity, its displacement in unit time always remains a constant. When a body travels with equal displacements in equal intervals of time, the velocity remains a constant. Then this way a body travels is called, the motion is called uniform velocity motion. In uniform velocity motion, when a body moves or travels, its velocity remains a constant. Therefore, acceleration is equal to change in velocity by time. Change in velocity is equal to 0. Why? Because velocity is equal to a constant. So in that case, the acceleration vector is called a null vector. It's a very important point, right? So null vector is a very useful term in physics, right? When we deal with vectors, it is very useful, right? So what the example, many examples say next, displacement of vector at rest is a null vector, right? A body is at rest at any time t is equal to 0. After some time, t is equal to t seconds, again you see the body, then also body is at the rest at the same position itself. So displacement is equal to what? Final position minus initial position is equal to 0. So final position minus initial position means both are same. Therefore, change in position of the body is equal to 0. Hence, the displacement is equal to 0. When displacement is equal to 0, that displacement can be said to be a null vector. A body who is at rest, whose displacement vector is a null vector, right? So magnitude of a null vector, as I said, is equal to 0, and it has an arbitrary direction. Arbitrary direction. Okay. Next is resolution of vectors. We will talk something about resolution of vectors also. Vectors can be of 2 dimension and also of 3 dimension. Right? In 2 dimension, the vector is bound by 2 axes. The frame of reference has only 2 axes. So the coordinate system can also be sometimes said as equal to frame of reference. We have a vector here, right? Now what we are going to do is we are going to split a vector into its components. When a vector is lying in a plane, it must have 2 components. When a vector is lying in the space, that must have 3 dimensions. 3 dimension means x-axis, y-axis, and z-axis. 3 components the vector must have, right? Suppose that a small insect is running over the surface of a table. In this case, the displacement of this insect is a two-dimensional vector. This